Welcome to the deep dive. So, for you listening, our core mission today is exploring this incredibly fascinating stack of development notes focused squarely on the frontier of AI-assisted software engineering.
Yeah, it's a really wild frontier right now.
It really is. And we are looking at what actually happens to software development after AI code generation becomes, incredibly cheap and just completely ubiquitous. Like, how do we verify that code?
Yeah.
How do we review it? And I guess most importantly, how do we actually maintain it over the long haul?
Well, the source material we are looking at highlights a pretty fundamental shift in the industry right now. I mean, we are reaching a point where the act of writing code takes seconds.
Literally seconds.
Exactly. But just because code is cheap to generate definitely does not mean it's easy to maintain. In a lot of ways, it actually becomes significantly harder.
Yeah, that makes sense.
The central dilemma of this whole new era is that the industry has to pivot away from writing code to the much, much more complex task of managing the AI agents that are actually writing the code.
Right. So, picture this scenario for a second. You walk into your office tomorrow morning, you sit down at your desk, and waiting for you is this infinite army of highly enthusiastic, totally free interns.
An absolute dream, right?
Right. I mean, they never need to sleep, they can type 1,000 words a minute, and they are just desperately eager to get to work. At first, it sounds like an absolute dream scenario. You can finally clear your entire project backlog.
Yeah, finally.
But then, reality sets in and you realize the actual nightmare isn't getting this intern army to do the work. The real challenge is making sure they don't accidentally bring down your entire corporate architecture while you aren't looking.
Which brings up the immediate question of oversight. Because when you have an army generating that massive volume of work, the traditional methods of checking that work they begin to break down under the sheer scale of it all.
Yeah, because if I have like 1,000 interns writing code for me, my instinct is just to run their code through our existing testing protocols.
Mhm.
We have unit tests, integration tests. If the code passes the tests, the feature does what the user wants, and the intern did a good job, we can just push it to production, right?
Well, our sources push back really heavily on that exact instinct. There is this explicit warning in the notes saying that an AI agent's code can pass every single test you throw at it, achieve literally 100% functional success, and still be deeply structurally flawed.
Wait, really? I have to admit, that sounds a bit counterintuitive.
I know, it does.
I mean, if the code worked perfectly, if it passes all the behavior tests and the end user gets exactly the feature they asked for, why does it matter if the internal structure is, as the sources call it, architecturally foreign? Isn't functional working code the entire point of software?
Well, in a traditional environment where human developers are maintaining the code base, yeah, functional code is the primary goal.
Hmm.
Because a human can usually look at a messy but functional solution and, slowly untangle it over time.
Right, humans can parse that.
Exactly. But tests only do one thing. They sample behavior. They verify that if you put A in, you get B out.
Mm.
What tests absolutely do not do is enforce architectural ownership
Mm-hmm.
or idiomatic structure or even discoverability.
Meaning the tests really don't care how you got from A to B, just that you got there in the end.
Correct. So an AI might solve a problem by writing code that works flawlessly, but it might do so by introducing a completely alien architectural pattern that your company has just never used before.
Oh, wow.
Or it might duplicate an existing concept. So let's say you already have a perfectly good user authentication module hidden away in a different folder somewhere.
Okay.
The AI doesn't know it's there, so it just writes a brand new one from scratch.
Oh, I see. It's basically an intern who didn't bother to read the company handbook, couldn't find the existing tool, and just brute forced a custom solution.
Yeah, that's exactly it. And in a world where AI is doing the maintenance, that custom solution just sits in the repository like a landmine.
A landmine. Yikes.
Because when the next coding agent comes along tomorrow to, say, add a new feature, it reads that weird duplicated code. And because an AI learns from context, it just assumes this weird code is the standard way things are done at your company.
Oh, no. So it learns the bad habit.
Right. It then replicates that bad pattern. You end up actively misleading the next agent, which creates this massive cascading failure of technical debt. One rogue AI writes something functional but strange, and the next AI takes that strangeness as gospel and builds an entire system right on top of it.
Man, that paints a pretty chaotic picture. I mean, if tests only check behavior and they completely fail to catch these structural landmines, we obviously need a different way to force the AI to understand the structure of the house. before it like starts knocking down walls and adding rooms.
Yeah, we really do. And the material introduces a concept to solve this called machine legibility.
Machine legibility, okay.
So human legibility is about making code easy for a person to read. Machine legibility is about structuring your coding environment so that it is inherently, like, unmistakably understandable to an AI agent.
Yeah. So a machine legible environment basically means a completely fresh AI agent, one with absolutely zero prior memory of your company, can drop into the code base and just immediately orient itself.
Yes, instantly.
It can find the code owner, identify the canonical pattern to use, run the correct checks, and actually know which paths are forbidden.
Exactly. It also requires the environment to allow the AI to clearly state its own uncertainty when it hits a wall. To achieve this, the sources highlight Google's specific case for using the Go programming language.
Right. Go.
Yeah, Go's design philosophy aligns remarkably well with machine legibility because it has a very small language surface.
I want to break down what a small language surface actually does for an AI. Because if I'm thinking about a language with a massive surface area, there might be, a dozen different ways to write the exact same function.
Right, lots of options.
But with Go, it's almost like we are building a bowling alley for the AI, and we are putting up incredibly strict bumpers. We aren't giving the AI an open field to run in. We are giving it extremely narrow choices so it literally cannot throw a gutter ball.
That's a great analogy. Those bumpers are structural. For example, Go uses static types, which gives the AI very rigid definitions to work with.
Wait, for anyone who isn't super get into language architecture, how do static types act as a bumper for an AI?
Okay, so think of variables in code as containers. In a dynamically typed language, like Python, for instance, a container can hold a number, then later hold a word, then maybe later hold a list.
So it's always changing.
Right. And the AI has to constantly guess and infer what is inside the container at any given moment, which uses up a ton of its processing power and invites a lot of mistakes. With static types, you declare exactly what the container holds permanently.
Okay, so it's locked in.
Exactly. It's a box for integers only. It basically gives the AI a puzzle piece with a specific, unchangeable shape. It just removes all the ambiguity.
That makes total sense.
Yeah. And Go also enforces standard formatting right out of the box. It provides a robust standard library and has highly integrated tools. The agent doesn't have to guess how to format a file or, which third-party library to import.
So the bumpers are just built directly into the language. Though I know the sources make sure to note that Go isn't the only way to do this.
No, definitely not.
You can achieve machine legibility in other stacks like TypeScript, Rust, or even Python. But the catch is that the developers have to actively build those bumpers themselves. You have to use really strict conventions and tooling to enforce narrow choices and provide deterministic feedback.
Right. You can't just leave it open.
Because if you just let an AI loose in a massive, totally unstructured Python repository, it will just get completely lost.
Oh, absolutely. You have to force the AI to make predictable decisions.
Yeah.
But, building those bumpers introduces a secondary challenge. The traditional metrics we usually use to evaluate code, like counting lines of code or measuring test coverage percentage, they are totally useless for measuring machine legibility.
Because, lines of code don't tell you if the next AI is actually going to understand what the previous AI did.
Exactly. We have to start measuring things we never quantified before. The new metrics focus entirely on AI code maintenance. We have to measure the rate of duplicate concepts like, is the AI recreating the wheel? And we measure convention distance.
Convention distance, meaning how far does a new piece of code stray from the company's canonical pattern?
Yep, you got it.
So say our company always queries the database using a very specific internal tool. If the AI writes a query using a totally different open source method, the code might still work perfectly, but the convention distance is incredibly high. It's just too far from our standard.
And a high convention distance basically guarantees the next AI will be confused. Another key metric is navigation cost. We have to measure how much token space an agent burns, just trying to figure out where a file even lives.
Let's define token space here real quick, because that's a term that gets thrown around a lot in AI. But in this specific context, it feels like a very tangible resource we are spending.
It really is. Token space refers to the AI's context window-like, the limited amount of text it can hold in its short-term memory at any one time.
Like it's working memory.
Exactly. Every time the AI has to read a folder structure, scan a file, or read documentation just to find what it's looking for, it consumes tokens.
Okay.
If your repository is a messy labyrinth, the AI burns through its token space just navigating. By the time it actually finds the file it needs to edit, its context window is full, and it essentially forgets the original task you gave it.
Wow, so we're essentially measuring how hard the AI has to think just to find its way around the folders.
Yeah.
And if the navigation cost is too high, the AI basically gets exhausted before it even starts typing code.
Which brings us to arguably the most vital metric discussed in the sources. We must measure whether the original design explanations actually survive the chat session they were created in.
That presents a massive logistical hurdle, honestly. Like, how does a design explanation actually survive a chat session? When a human developer is managing these agents, what does that survival actually look like in practice?
Well, we have to look at the fundamental limitations of an AI agent's memory. When you are chatting with an AI in a prompt window, helping it design a feature, it understands your intent perfectly.
Right, because it's reading the chat history.
Exactly. It has all the context of your conversation.
Hmm.
But the moment you close that browser window, that specific instance of the AI essentially dies. Its contextual understanding is entirely fleeting. It has complete AI amnesia.
AI amnesia.
Yeah. The only thing that remains is the actual code it committed to the repository.
So if the AI doesn't leave a perfect, totally unambiguous trail of breadcrumbs explaining why it made certain choices, the next AI that logs in tomorrow will have absolutely zero context. The code base itself has to hold the entire memory of the conversation.
You nailed it. And the sources dictate very specific tools to ensure this survival. You use progressive repository instructions, which guide the agent step by step rather than just giving it one massive prompt.
Keep it bite-sized.
Right. You also use executable constraints rules that are enforced by the system, not just written in some text file as nice suggestions.
Okay.
You demand semantic names, so the purpose of a variable or function is completely obvious without needing a whole paragraph of explanation. And you ensure there is exactly one focus check and one completion check.
Wait, why limit it to just one focus check? If we're so worried about the AI breaking things, wouldn't we want to hit it with as many checks as possible to be safe?
You'd think so, but it comes back to that token space limitation we just discussed.
Mm.
If you hit an AI with a wall of, say, 50 different test failures from across the entire code base, it just gets completely overwhelmed.
Burns its memory again.
Exactly. It uses up its context window trying to read the errors, it panics, and it starts making hallucinated fixes that break things further. One focus check provides a very narrow deterministic piece of feedback. It tells the AI, fix this one specific boundary before you even think about moving on.
Got it. Since the AI's memory dies completely when the session ends, and we're relying on the codebase to be the sole record of truth, we really have to address how a task is actually handed off. We need a solid bridge between the AI that just finished working and the AI that starts tomorrow.
Yes. And the sources call this bridge the durable handoff receipt.
The durable handoff receipt.
Yeah, because AI agents are fundamentally amnesiacs, you cannot rely on implied knowledge. The handoff receipt is a formalized, highly structured document left behind by the AI that just finished its task, specifically written for the AI that will pick up the next task.
So it's basically a meticulous shift change log at a hospital.
Exactly like that.
Like the outgoing nurse doesn't just pass the incoming nurse in the hallway and say, hey, the patient in room 3 is fine.
Right, that would be a disaster.
They rely on a rigorous protocol. They list exactly what medications were given, what the vitals are right now, what treatments were intentionally skipped, and what the incoming nurse needs to watch out for. It leaves absolutely nothing up to interpretation.
That's a perfect analogy. And the source material actually lists the exact elements that must be in this AI shift change log.
What are they?
Well, a proper handoff receipt names the specific task that was just completed. It lists the base commit.
Meaning the exact starting point in the version history, so the new AI knows exactly where the changes began.
Yep. It also lists exactly which files were changed.
Yeah.
And it identifies the authoritative abstraction.
I want to clarify authoritative abstraction real quick. Is that essentially the AI declaring the core logic pattern it shows, like saying, hey, I chose to build this feature using Legos, not erector sets, so the next agent knows to only bring Lego pieces to the project.
Yes, that captures it perfectly. The receipt also must document the intended behavior of the new code, as well as the unchanged behavior, like what the AI intentionally left alone, so the next agent doesn't try to, quote, fix something that isn't actually broken.
Oh, that's smart. Keep it from tweaking things randomly.
Exactly.
Yeah.
And it logs the specific checks that were run and their exit codes.
Exit codes being the literal system signals showing if a process crashed or succeeded. Again, just completely removing all ambiguity. It's not the AI saying, I think the test passed. It's the AI logging the exact system confirmation.
Precisely. And most crucially, the receipt requires the AI to state its own uncertainty and then prescribe the safest next action for whoever takes over.
State your uncertainty. Wow. Forcing the AI to literally mathematically admit what it doesn't know before it clocks out for the day.
Right.
That fundamentally changes how you manage a project. But how do you actually verify that the AI wrote a good receipt? I mean, how do you know it didn't just hallucinate the log?
The material offers a really great pro tip for verification, the clean agent test.
Okay, what's that?
To verify that your environment is machine legible and that the handoff receipt actually works, you fire up a brand new, completely context-free AI agent. You don't give it any background information or history of your previous chat sessions.
A total blank slate.
Yep. You just point it at the repository and the handoff receipt, and you ask it to act as the next maintainer and extend the patch.
Oh, I see. So you throw a completely blank slate intern right into the deep end, hand them the hospital chart, and just say, perform the surgery based only on these notes.
Pretty much. And if the clean agent can pick up the work and continue without getting confused, without burning through its token space or breaking the architecture, then you know your system is bulletproof. The repository evidence truly survived the original conversation.
Tying this all together practically, I know the sources outline a project called What We're Building This Week to kind of crystallize these concepts.
Yeah, to put it into action.
And the goal of that project is to build a repository map. This map establishes strict walled gardens for the AI. It dictates, one owner per package, one focus check per package, and a totally forbidden boundary that the AI just cannot cross.
Right.
And alongside this map, you run that handoff evaluation where the clean agent safely extends another agent's patch.
Exactly. It's about proving the system actually works in the real world.
So for you listening, I want you to think about your own daily workflows. Whether you actively write code, manage complex projects, or even run a whole department. How much of your current environment relies on human intuition?
Probably a lot more than we realize.
Oh, totally. How much relies on someone just knowing how things are done because, well, they've worked at the company for 5 years? As AI becomes the real engine of our daily work, this whole concept of machine legibility is going to leap way out of just software engineering and applied to literally every tool we use.
Without a doubt.
We are all going to have to start constructing these strict bumpers and leaving behind durable handoff receipts.
The trajectory is super clear, but connecting this to the bigger picture leaves us with a pretty profound paradox to consider.
What's the paradox?
Well, we are talking about entirely restructuring our code bases, our programming languages, and our core metrics. We are actively narrowing all of our choices and creating these hyper-rigid file structures and cryptographic handoff receipts.
Yeah.
But we are doing all of this, optimizing it perfectly for the mind of a fresh amnesiac AI agent.
Right.
And we optimize an environment so completely for a machine, we really have to ask if we are quietly engineering human legibility out of the equation entirely.
Oh, wow. I hadn't thought about that.
Right. If a system is built exclusively for an AI to navigate, will a human developer ever be able to just open a file and read it naturally again? Or are we essentially locking ourselves out of the very buildings we are constructing?